Good morning. This is Jim with We Develop Electrical Products. We've got our 8th project here with the Arduino for beginners. And in the description below, you'll find links to the previous 7 projects with the Arduino for the beginners, along with some links where you can buy the Arduino and the LEDs and resistors and those types of things, the breadboard that we've been using for these projects. And you can just go to those sites and purchase those there. And today we're going to be talking about a project of blinking the onboard LED without using the delay function. If you remember in the script, in the examples under basic, we had the blink function where we got the Arduino to blink the onboard LED. This was one of the first projects that we did, and we were doing a digital write down here. We would digitally write a high to the built-in LED, and then we'd delay for 1,000 milliseconds, and then we'd digitally write a low to that built-in LED and delay for another 1,000 milliseconds, and then we go back up and we repeat all over again. So we're using this delay function in here to delay it a second on each one of those operations. What that does is it causes the program to stop and count the number of milliseconds before it proceeds to the next step. So if you have other things that you want to execute in the program, they're delayed by this 2 seconds as well. So in order to avoid that, what we're going to talk about today is a way of doing that without using the delay function so that other parts of your script can execute while you're waiting for that delay. And basically we have to assign a few variables. We assign the LED out as an integer to the built-in LED. That's just going to be a constant variable of LED out, and that's going to be the pin 13 or built-in LED. And then we're going to assign an unsigned long to last time LED millis. And we use an unassigned long because here we're using the internal clock of the Uno. And if you use an integer, it's going to overflow before too long because that clock is going to exceed the limits of the memory for an integer. So we use an unsigned long, and that will continue to store the number of milliseconds for up to, I believe it's about 40 days before it'll overflow. And then we're going to assign another long of delay time, how long we want it to delay between the going high and going low on that LED to turn that LED on and off. And we're going to assign that 1,000 milliseconds or 1 second. And then we've got an integer, which is last LED state, just to keep track of the state of that LED. And we're going to start that out at a low. So we're going to start out with the LED being low. And then we've got the void setup section here. And we got a pin mode. We're just setting that LED out to an output. So the LED out that we defined up here as being LED built in, we're going to define that down here as being an output. And I just have this serial begin in here, 9600, so I could print out some of these variables during debug. We don't need that, but I'll just leave that in for the time being because I got rid of all my serial writes to write out all these variables during the debug cycle. And then we've got our loop. We're going to go down here and we're going to have an unsigned long of time. We're just going to keep track of the amount of time between the clock. So that assigns an MILIS, and that's the milliseconds on the internal clock, and we're going to assign that to time. Then we're going to go down here and we're going to do an if statement, and we're going to say, okay, is that time, the number of milliseconds that have gone by, minus the last time in milliseconds, and that last time in milliseconds we started out at a 0, is that greater than or equal to that delay time of 1 second? If it's not greater than or equal to the delay time, we're going to drop down here, and we're just going to repeat this loop. Actually, we're going to write the last LED state, which is a low, to the LED out, that built-in LED pin, which is going to still remain as low. And then it's going to go back up and it's going to take the next time that has gone by and add it to that, or put that in the time slot. And it's going to come down here and do this if statement again. And this time, if it is greater than or equal to the 1 second, or the delay time, then it's going to go down here and it's going to set that last time LED millisecond equal to the time that has gone by. And it's going to go down here and it's going to ask a question. If the last LED state was equal to a low, then it's going to make the last LED state a high. It's going to flip it from a low to a high. Or else, if it's not equal to a low, if it's equal to a high, in other words, it's going to go down here and it's going to say, okay, that last LED state, we're going to make that a low. So it's making the decision here whether to flip it from a low to a high or a high to a low. And then it goes down here to a digital write, and it makes the last LED state and writes it out that last LED pin. So now you can see where other functions could be taking place in your script, and we're not delaying at all the script functioning and executing. So this is how you get away with not using the delay function and letting other parts of your script execute while you're waiting for something else to happen. So if you like this video, please hit the like button and share it, and subscribe to my video, and you'll be notified when future videos come out. So have a good day and enjoy working with the Arduino.